time we talked about generating equations. So all those stuff about finding initial values, about generating equations from a graph. So today we'll be mainly talking about generating a graph from an equation. But before that, actually, I want to kind of go over the first two questions in the homework from last week. Let me just get that out. So the first question, I just realized after I posted that I didn't really talk about this type. But because it doesn't have an exact y-intercept. But you could use slope points, no, yes, point slope form. And then that would be able to give you an equation. So good job to the people who used point slope form. But essentially, so this one, right? So it's because it doesn't have a y-intercept. So when we try to use this, we don't really know what the y-intercept is. So for this reason, we cannot use this. So what we must use is a point slope form. We need point slope form to generate the equation of the line. So this question really should not be the first question. That's my bad. I did not realize this graph was cricket. So this should not be the first question. The first question should be what equation represents the relationship between time and temperature of the pizza. So just looking at the graph, some things that you should notice. So this is the temperature as time goes on. So the temperature goes up. So that means when you have the rate of temperature change should be positive. And then initially it was at negative temperature. So that probably means it was taken out from the fridge. Yeah, it's taken out from the freezer. So that's why it's negative. And it gradually heats up, linear relationship. So to use point slope form, oh god, my writing's messy today. Let me try to write neater. So if anyone still remembers point slope form, it is that when you have y minus a coordinate, the y coordinate of a point divided by x minus the x coordinate of a point is equal to the slope. So, or how I usually wrote it was like this. But they essentially mean the same thing. So these are interchangeable. Well, so first you need the slope. So find the slope, same deal as always. You pick 2 points, so this point and this point looks pretty legit. So I find the y's over the 1. That's how I find the slope, as always. So this is the change in y is 10, and the change in the x is Oh, this here is 3.25, I believe. Yes, this point here is 3.25. So 3.25 minus 2, that's 1.25. So that means we have slope is equal to 10. So let me write out the change in y divided by the change in x, and according to the graph, that is 10 divided by 1.25, and that's equal to 8. So the slope of this graph, so the slope also represents how fast the temperature is rising, how fast the temperature of the pizza is rising as time moves on. So I should probably include a unit because this is a word problem. It's 8 degrees Celsius per minute. So when I marked your homework, I didn't really mention this, but if you leave out the units in an actual class, so in school, the teacher can actually take off marks. So I didn't really say you're wrong, but then the teacher will take off mark if you don't include the units. Because this is a word problem, and there will be no meaning to any number without units. But anyway, so let's go back to the point slope form. So y minus a y coordinate divided by x minus a x coordinate. So I'm just gonna choose this point over here. So this point over here, the x coordinate is 2 and the y coordinate is 10. That's this point. So this means that in point slope form, y minus 10 divided by x minus 2 is equal to the slope, which is 8. So if I multiply x minus 2 on both sides, I will be getting y minus 10 is equal to 8x minus 2. Is that right? Oh, no. Minus 16. Huh, my bad. So if I add 10 on both sides, yeah, minus 6. So that will be our equation. So the y-intercept is therefore negative 6. Now it looks like a whole number, but the reason why it doesn't show up here is because the scale, this is counted in 5. So you can't really say whether this is 6 or not. But now we know that the y-intercept is 6. Negative 6. Negative 6. So I chose 10 and 2 as my point, but of course you can choose any point. And when you simplify it down to slope-intercept form, you should be getting the same equation. So this part might be different, but this final part here should be the same, whatever method you use. So what does this represent? It shows that, so it's representing the relationship between the time. Time is our x value, and then temperature is the y value. So x and y. So this here, initial temp, and then x over here is time, and y is temperature. So you must always be cognizant, so always be aware what the variables represent. So if you so in the homework, if you got it messed up, so if you got the time and temperature messed up, then you will get a completely different answer, which is wrong, which wouldn't make sense. So you got to make sure that you are aware of what the x value is and what the y value is, because after all, they're just variables, and variables represent something, and x represent time, y represent temperature. So there's your equation. So now if I ask you, uh, what is the initial temperature of the pizza, I would have just -6. Or, so it's because it's the y-intercept because x is equal to 0, right? So let's say you don't get to this part, you just left it in the point slope form. That is totally fine as well. So let's say you left the equation as this. So you didn't simplify it. So the initial temperature is when, so actually let me move this down and then move this over here. Now, so we know this is our answer. So that's the correct answer. But using another method, so the initial temperature is when time equals to 0, right? So this means you can plug in 0 in this equation and you should be getting the y, the temperature, y. So let's try plugging in time is equal to 0. So time is x. So y minus 10 divided by 0 minus 2 is equal to 8. So y minus 10 divided by -2 is 8. So now if I multiply both sides by -2, I would get y minus 10 is -16. So y is, so add 10 on both sides. Yeah, y is equal to -6. And this they are equal. So we know -6 is the right answer. So there we have answered the question, what is the initial temperature of the pizza? So teachers in school like you to give a sentence answer for a real problem, and I can understand why, because so this is not that much work, but imagine you have a uh, really long page of work, like say it goes up to here, go down to here, then and then you have so many values, so many variables, they won't know which one is the right answer. So that's why when you have real problem, people like teachers like to want you to present a sentence answer. So I can say uh, the initial temperature of the pizza is -6 degrees Celsius. So that's all for this one. So any question about the first two? So the first one was generating an equation. So that's our equation that we generated. And then the second one was about finding the initial temperature. No question? Okay. So now, this question is what is the initial temperature, right? So if I ask you to find what is the temperature, no, what is the temperature at, say, 2 minutes, then all you got to do is plug in 2 into the x. Oh no, yes, plug in 2. But actually, you would not want to plug in 2 over here because you get 2 minus 2 is equal to 0. So you have to move it over. So this form, plug it into here. So plug in 2, so what's the temperature at 2 minutes? 8 times 2 is 16. 16 minus 6 is just 10. So the temperature will be 10. And let's say, how long will it take for the pizza to reach? So maybe let me do that one. That one might be a bit confusing. So to reach 18 degrees Celsius, let's say. So our relationship is y is equal to ax plus 6 minus 6, where y is the temperature and x is time. So in this question, we do not have time. We are needing to solve for time, but we do have y. We do have the temperature. So therefore, instead of plugging in the x, you plug the 18 into y. So this is why, again, you have to really be aware of what the variables represent. Because if you plug in 18 into x, that means that what is the temperature at 18 minutes? And that is completely different from this answer. So be aware of your variable. So y, 18, I plug it into here. So 18 is equal to ax minus 6. So I can just add 6 on both sides. And I get 24 is equal to ax divide 8. X is equal to 3. So again, what does this represent? Let's answer the question with a sentence. So it will take 3 minutes for the pizza to reach 18 degrees Celsius. So we are solving for how long it takes. So if you go back to the graph, that should kind of make sense as well. Because at 3, so after 3 minutes, that's what we found. We go up the graph, we see that this here is indeed around 18. So we don't know the exact marking because it doesn't have it on the graph, but kind of like 20 and then 15 is closer to 20. So it must be around 17, 18. And yes, this is 18. It's precisely 18 at 3 minutes. So that wasn't the second question. And that wasn't in the homework, but it's something similar to this. So of course you have to get the relationship right first. So if you mess up the relationship, mess up the equation, you get everything wrong. So, so you got to make sure that your equation is right. Then you can plug in numbers and solve. But yeah. Uh, uh, that being said though, so if you meet a nice teacher in higher grades, then if you say you get the equation wrong, and you use that equation to keep doing the later questions. If you plug in the numbers into that wrong equation and got out a wrong answer, but the wrong answer corresponds to the wrong equation, then the teachers will still give you correct answers for the later questions. So let's say the equation becomes you wrote it as ax minus 5. Why? So that's a wrong equation. And then initial temperature, you said negative 5. So even though it's wrong, but if it corresponds to the equation, the teacher will still give you the right answer. But that's if you meet a nice teacher. If you meet a not so nice teacher, they'll just mark everything wrong. And that's not very good for you. Usually, this is a question. So usually this is out of 2, maybe sometimes 3. This one is out of 1. And this one usually out of 2. And then there will be another one where it's like so what will the temperature temperature be at 5 minutes? So this is the other classic problem that teachers might ask, and this is again out of 2, so I won't solve this. But so in total, this whole question is out of 2, 4, 6, 7. So a question like this, if it is a written question, it is out of 7 marks. And say that you must get the right answer to all of them. If you mess up the first question, so you show your work and you got the wrong answer, but your work is kind of correct, then you might get like a 1 for the first part. But that's all you get because everything else is wrong, so minus. So if you get the wrong equation, worst case scenario, you end up with that's the mark you get for that question. And that is not very good. Now, if you meet a nice teacher, of course, you still get 1 for this and 2 for that and 2 for that. So you get 6 out of 7, but that's not always the case. So this is a 7-mark question. So make sure you get the equation correct in the beginning. So equation, we found the equation, and the initial temperature, we plug in the x value equal to 0, or you just look at the y-intercept, it's negative 6. And then how long will it take for the pizza to reach 18 degrees? So 3 minutes. So that's the first question of the homework. So if you got the second, so if I gave back the homework feedback, and if you got the second question wrong, then try it again using what I talked about here today. So maybe what I would do is I'm gonna switch back to the grid format graph. Yeah. Wait, this is not the graph I usually use. Huh. Okay. Guess I'll use this. Nope. Let me switch the graph. I don't like this one. Sorry. Here. Yes, that's better. So guess I'll do it here. So you can assume that every box is an increment of 1. So maybe let me just, this is 5 here, and then this is 10, this is 15, and same thing here. 5, and this here is 10. Okay, so, and then I'll have a graph that looks something like this. Oh, no, this point should be here. Centimeters, and then this here is days. So some background information. The graph above represents the height of a plant over time. So it didn't start at 0 because let's say I bought it in the store and it was already growing. So that's why the initial height was not the actual initial height. So the actual initial height should be 0. When it's just a seed, it should be 0. But in this question, we assume that the initial height is not 0. But this, so anyway, this line represents the height of a plant over time. So first question is, how fast is the plant growing? So try this one out. And when you have an answer, just type it into the chat. So that's the key. How fast? No, Bell. Any ideas? No? Chloe? What's the answer? So 1/3 is the slope, but this is a word problem. So could you give me the units? So that is the slope, but what are the units? Question mark, question mark. Okay, so the change is for every 1 centimeter of change, you have it takes 3 days. So 5, 6, 7, 8. So let's say I use these three. So it takes 3 days. So the rate of change is therefore the slope. So it's 1 centimeters for every 3 days. And you can technically leave it as that. For every 3 days, the plant grows 1 centimeters. So that's the importance of the unit. It tells you what it represents. So for every 3 days, the plant grows 1 centimeters. Or you can technically divide this, like actually divide it. So then you would get, so you won't get an exact number now. You get approximately 0.33 centimeters per day. So so for every day, the plant grows approximately 0.33 centimeters. So if you multiply this by 3, you get 0.99 oh wait, no. Sorry. 0.00 0.033. That's right. So if you divide this out, you get 0.033 centimeters. Wait, what am I doing? No. I was right. Yeah. So if you multiply this number by 3, you get approximately 0.99 centimeter for every 3 days. So this is matching up with 1 centimeter for every 3 days. So the other way you could look at it is every day the plant grows 1 my bad, 0.33 centimeters. So that's the unit. So the unit for the y-axis is centimeters, and the unit for the x-axis is days. So that's how you get the centimeter over days. So with that in mind, now I want you to find the equation that represents the relationship between height of plant and time. So the x-axis is the times and the y-axis is the height. And so you essentially find the equations that tie those two variables together. So I'll give you to 3 minutes. Shouldn't take you really that long because we have been doing graphing for the past 2 months almost. Give this a try. And no, you cannot determine what the y-intercept is. This is unclear. Oh, I'm not speaking right now. I'm just waiting. Wait, Chloe, so that's your answer? Minus 17? That means you have a y-intercept of negative 17. But this is very positive. This graph is a very positive graph. Oh no, you can't hear me. No? Can everyone else hear me? I think so, right? So Nobel, 1 over 3x plus 2. Okay? How come? How did you come up with the equation? Could you tell us your process? Not saying it's right or wrong. Yes. Any ideas? Oh, did someone else get a different answer maybe? Or same answers? Olivia, what did you get? No answers. Okay. So 1 over 3x plus 2 is pretty close, but not quite. And 1 over 3x minus 17, this is, that would that would indicate that the y-intercept is right down here. It would be something like this, but no. The y-intercept is positive. This whole graph is very positive. 2.5. Okay. 2.5. That looks about right, but still a bit off. Still a bit off. Oh, Nobel, you have something to say? No? Oh, so key is to use point slope form. And for point slope form, you need a point. Is this one? This one here is 11 and 6. Is that right? Yeah, 11 and 6. So y minus the y coordinate divided by x minus the x coordinate. No, got it mixed up. Y minus the y coordinate was 6. Divided by x minus the x coordinate is equal to 1 over 3. Multiply 3, cross multiply. Get 3 times y minus 6 is equal to x minus 11. So I expand this. 3y minus 18 is equal to x minus 11. Add 18 on both sides. 3y is equal to x plus 7. So just to simplify it a bit, I get y is equal to x divided by 3 plus 7 divided by 3. So there's the equation. So the slope is indeed, right, so maybe. So the slope is indeed 1 over 3, as we found in the previous question. So this is your final equation. And the y-intercept is not 2, not 2.5, just in the middle of those two answers. 7 divided by 3 is approximately 2.33. And I said the graph, you don't know what the y-intercept is. You cannot just look at the graph and say it's 2 or 2.5. It's 2.33, around there, 7 over 3. So that means the y-intercept is 7 over 3. So on the graph, this is represented right here. And again, your variables, y is the height of the plant, and x is your time. This is centimeters and this is in days. Keep the variables in mind. Okay? So it's different from the ones we did last week because of the fact that you have to use Poinsot form. Cannot just have a y-intercept visibly seen. You need to calculate it and find out what the y-intercept is. So, like in this process, really the mistakes are on calculation. So just please watch your calculation carefully. Like if you're gonna distribute everything. Don't just distribute the 3, the y, and leave the 6 alone. If you're going to add 18 on both sides, make sure it's add, not subtract. And yeah, just the tiny calculation errors will cost you a lot if they. So it's pretty straightforward. Same thing as always. What is the height of the plant after growing for 3 days? Anyone want to answer this? Just type it into the chat. And I even got the variables listed out here. 7 over 3 days. That's the initial height already. So it didn't grow at all in 3 days. So 7 over 3, that is 2.33. That is the initial height. Oh, maybe check your calculation again. I think I might know what happened there. Good try, but check it again. Is that supposed to be 13 over 3? or 2. And I got an answer for Chloe, 10 over 3. So let me do it and see which one is right. Times 3 plus 7 over 3. So I cancel this out, but that doesn't mean it becomes 0. It becomes 1. So it's 1 plus 7 over 3. So to add, you need a common denominator, of course. 10 over 3 is the correct answer. After 3 days, is 10 over 3 centimeters. Make sure your calculation is correct. That's right, Nobel, 10 over 3. No. How long will it take for the plant to grow to 1 meter? Be careful here, okay? It's meters, so need to do something else before you can. So the y-axis, if you don't remember, is in centimeters. But this question is in meters. So you probably need to convert it first. The units must match. So try again. Olivia, you might want to redeem yourself with this question. That would be a good idea. Okay, so Chloe got 293. Oh no, you can't hear me again. Can you hear me now? I am speaking right at this moment. And okay, Nobel got 293 as well. Well, I wasn't speaking, Chloe. That's why you couldn't hear me. So, yeah. So if you see so maybe just for future reference, if you see the green thing around my profile picture, I guess, like that means I'm speaking. And if you can't hear me at that point, then it's something wrong with the technology. But if it's muted, like not muted, if it doesn't light up, so like right now, then that just means I'm not speaking. So, okay. So 293 is the correct answer. So 1 meter, so 100 centimeters. Therefore, it's the height. So I plug in the y value. So then, essentially, got to convert this into a fraction first, all with the common denominator. Then I can minus the constant term on both sides, which would give me 293 divided by 3 is equal to x divided by 3. So if I multiply 3 on both sides, the 3 in the bottom cancels out. I'm left with 293 is equal to x. And remember the units. X is in days. That didn't change. So answer. It would take 293 days for the plant to grow to 1 meter. So when you're answering the question, you probably want to answer in terms of what the question asks. So I guess you can say 100 centimeters, but it's just nicer when it's answering directly with the same unit as the question itself. But what's important here is this. So as long as you get that part. So again, don't mess up on the calculation. The equation is pretty straightforward. So there you go. So I will give you some questions like this in the homework. And yeah, so if you have any questions, you can ask me right now or after class. But I think I am going to move on. So don't really have much time left. So I'll just do one example of going from equation to graph. So given an equation, so given a relationship, I should say. Oh, so given a relationship between two variables. So let's say I have a y is equal to the classic y is equal to mx plus b. So it's pretty much the same, except you're doing the reverse now. So graph this as the y-intercept, and then graph this as the rate of change because it's the slope. So I guess I'll just give you an example to look at, and then yeah, it's not much. What you have done is taking the graph and collecting the information from the graph and putting it into equation form. But now you're just doing the reverse of that. So uh, example, the relationship between uh, time and distance of a car is modeled by the equation d is equal to 50t plus 25. Yeah, actually no, just 50t for now. Where d is the distance traveled and t is time traveled. Graph the relationship. So, so these are two different variables. I didn't use y and x this time, but after all, they're just variables. So technically, you can graph this on the x-axis or on the y-axis. Doesn't matter. And same with this one. No, they can be anywhere. But as you have seen with the examples in the past uh, two lessons, usually we like to have the time on the x-axis, and because that's the independent variable, and the y-axis would usually be the dependent variable, which in this case is the distance. So I'll set up the graph, something like this. And so it goes up, so 50 here is the slope, right? So that means for every time I go across, I will go up 50. So I probably want the increments to be a bit different from the different axes. So for this one, I'm gonna say this is 50, and this is 100. Maybe one more increment, 150. So this here is, oh, I forgot the units. Let's say this is in kilometers. My bad, forgot the units. And this here is in hours. So the increment for this may be so 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'll say that this is 1 hour. 1. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 2. And it goes on. So the increments are different. When the increments are different, you want to label them. So the slope is 50. That means when it goes across 1 hour, it goes up 50. Goes across 1, goes up 50. And just keeps going. So across 1, up 50. And then the y-intercept is 0. I didn't include a, so it's just 0 here. So I just got to plot the graph. And that's all for this question. Just recognize the slope and recognize the y-intercept, which is 0 in this case. And it's always a nice thing to write out the equation right next to the line. Sometimes the teachers even require you to do that, but oftentimes no. But it's still a nice thing to do. Now, so when you draw the graph, make sure increments. No, I'll write it here. Make sure to label increments. So my 2 increments here are different. So especially when they're different, then you must label them. And then label axes, I should say, right? Axes, yes, axes. So axes are these. So I forgot to give it to you, this question, my bad. But when they're given, you must label the axes. And then just look at the slope and y-intercept and graph. So the nice thing about transforming an equation into graph is that usually most of the times I should say, the equation will be in the form and will be in slope intercept form. So it will probably have a very clear defined intercept and the slope will be pretty clearly defined as well. You won't be seeing a lot of point slope form or for the sake of matter, standard form, which we haven't seen in ages. But yeah, most of the time it will be in this form. So all you gotta watch out is the slope and the y-intercept. It's really not much variation to these type of problems. So I'll just do another one, last example for the day. So use a pizza example again. So the relationship between the temperature of pizza and time is modeled by the equation y is equal to 4x minus 2. where y is equal to the temperature in Celsius, degrees Celsius, and x is the time in minutes. Graph this relationship. So first thing, draw the axes. So before you start drawing, you got to look at the equation and recognize that there's a negative value for the y-intercept. So probably want to go down a bit more because we're going to touch on negative area. And then, so the slope was 4x, that means it goes up 4 degrees Celsius for every minute. So minute, and then this is degrees Celsius. So I think I'm just going to use one box as one increment. And when you have that, you don't need to label the axes. So you don't need to label, no, you don't need to label the increments. You still need to label the axes. So you need to label the increments when they are not one box per one increment. So I'm doing one box per one increment. I'm just gonna leave it like that. So y-intercept, -2, somewhere here. And then the slope is 4. So that means when I go across one, I'm gonna go up 2. Cross one, go up 2. So combined with the y-intercept at -2. The temperature of the pizza as a function of time is something like this. Yep, there you go. Oh, that's not very nice, but yeah, I'm gonna label this right at this point. Another point, another point, another point, another point. So that's all. Pretty straightforward, I think. Just label the y-axis and then follow the slope. There's the graph.